A black hole is the ultimate triumph of gravity. It's gravity so strong that not even light can escape. My name is Chris Stone and I do black holes. I'm a professor of astrophysics and I get to study gravity at its most extreme. There was a program on TV called Star Trek and I loved it. The character I really engaged with most was Spock. I just loved the idea of the science officer being the one who understood stuff. And so I really wanted to understand how materials worked, how space worked, how stars worked. And so I studied physics. I started realizing that we could describe and understand black holes. And so it was an interest that grew as I went to university. I'm just really fascinated by gravity. I just wanted to understand how gravity works. And black holes are the most extreme form of gravity. To give you an example, if I was to turn the Earth into a black hole, I'd take the whole mass of the Earth and I'd squash it down and squash it down, squash it down until it was between my thumb and forefinger, less than 1 centimetre in size. That's how extreme gravity has to be to trap light inside. So the way we understand black holes all comes from Einstein and his amazing ideas about gravity. When Einstein first came up with his theory, people realized that it could lead to black holes, but they thought surely nothing so extreme could ever happen in the real world. And so they just remained this speculative idea for years and years until the advent of rocket science. The great thing about rockets is you can get above our atmosphere. Our atmosphere blocks high energy radiation, things like X-rays and gamma rays. And while a black hole on its own doesn't produce any light, by definition light can't get out, most stars actually don't live on their own. Most stars are in binary systems, so there's a star next door that can be lunch. And material falling from the star into the black hole gives out so much energy. It comes out as X-rays, and with rockets we can see those X-rays. There's 2 types of black holes. There's black holes that form at the end of the life of the most massive stars. Live fast, die young. The most massive stars, clearly they've got the most fuel, but they burn through that. They burn through that fuel in fusion, and when they come to the end of the fuel, gravity never goes away. And there's an enormous gravitational compression that happens at the end of the life of the most massive stars. That compression is so strong that there's nothing that can stop it from collapsing into a black hole. And that's the death of a star, where gravity takes over and no light ever gets out. There's so many things we don't yet understand. We don't understand yet how the material falling down onto the black hole can sometimes produce incredible energetic jets coming out. That we really don't understand. And that makes a big difference actually to the evolution of the universe as a whole. We talked about the black holes that you get as the result of stellar death. But there are also huge black holes, supermassive black holes that lurk in the centers of most galaxies, including our own. The energy that comes out from the material falling onto these supermassive black holes can affect the evolution of that galaxy as a whole, controls star formation across the entire galaxy of stars. The one in our own galaxy, there isn't very much material falling onto it at the moment, so it's not very active. But some of the ones in other galaxies, there's a huge amount of gas and dust that's falling down into that huge gravitational potential well. And the enormous amounts of energy coming out are transforming these into the brightest objects in the universe. These are the quasars. We can see them across vast distances to when the universe was only a tiny fraction of its current age. If you fell into one of these stellar death black holes, then what would happen is as you were falling towards it, you'd get to a point where your feet were falling faster than your head and you'd get stretched out and ripped apart. Not a good way to go. But if you were falling into one of these really supermassive black holes, then the size scale of a person relative to the size scale on which gravity is changing is much smaller. And so you could actually fall into the black hole. You could fall within the region where not even light can escape. And you could see what happens underneath the event horizon itself. Now, you'd never be able to tell anybody what you had seen, but you would be able to see it before you were crushed out of existence at the singularity.